Yeah, Lisa's really excited.
My first story told me.
Okay, so today, when we start this next unit, we are going to learn what to do with angles of in between. Okay, so the in-between angles we're going to learn about are the 15s and the 75s. So let's start by writing them on our unit circle. So give me a 15 degree there and a 75 degree there. What's the number on the other side of 90 then? 105, is that what you said? Okay, what's between 150 and 180? 165. Between 180 and 210? 195. And before the 270? 255. What are we here? 285? 285 and 345? Okay, now let's get all those numbers in radians. Oh, so let's just talk for a second here. 15 degrees. It's actually not too bad. 15 degrees is 180 divided by, anybody know their numbers?
1, 2, and 3, maybe.
How much would you have to divide 180 by? What? 180 divided by, well, 180 divided by 3 was 60. 180 divided by 4 was 45. 180 divided by 6 is 30.
8.
180 divided by 8, no.
7. 12.
We got it. We got it. 12. If you take 180 divided by 12, you get to 15.
That's what I was thinking.
And
Yeah, people have a chance.
are you okay if I, instead of writing 180, I write pi?
Oh, yeah. Okay.
Okay. So, here we go. This is pi over 12. Does it also make sense because this is pi over 6 and that's half of that?
Yep.
Yeah.
Okay. Okay. What is a half? What over 12? 6. So then this is 5 pi over 12.
Oh, they're all 12.
And this is, if this top was 6, 7 pi over 12.
You've seen small radians.
Okay, the 180 line is what? 12 over 12?
11 over 12.
So this is 11 pi over 12. And past the 180 then is 13 pi over 12. Do you know what is the number on the bottom? So if this was 6, 12, what's directly on the bottom? 18, yep. 6, 12, 18, 24, right? So if the bottom is 18 twelfths, then this is 17 over 12, 19 over 12, and the whole entire circle is 24 over 12?
Yeah.
So then 23 pi over 12. Ta-da! You've just done all of the 15 and 75 degree increments.
That was rough.
So there could be like infinite number of degrees in between. You could do like the tens.
How much
You
radians?
could,
And you could do like the ones.
but we won't.
What?
And the 0.5.
We're done. That's the last angle we're gonna do.
What did you do in the first?
Okay,
What are you talking about?
now
Probably.
I am going to
Yeah, you actually.
use angles that I know stuff about,
I'm gonna lie.
and I want to get to a 15. The angles I know are 0, 30, 45, 60, and 90. Those are the angles I know trig values to because of the circle. How could I get a 15-degree angle using the angles that I know, and I'm specifically going to pick 45 and 30?
Yes.
Does 45 subtract 30 make
Yep.
you a 15?
Want
How
to add it?
how could you get 75?
Add.
You could add them.
I like these questions already.
Okay, you could obviously just make that language into radians, but we're not going to. Okay, find the exact value for sine 15 degrees. So instead of doing sine of 15 degrees, I'm going to do the sine of, and then I replaced 15 with 45 subtract 30. Does that make sense? Is that okay?
Why? Go.
Why? Is because I know stuff about sine of 45 and I know stuff about sine 30 because of my circle. Sine of 15, I don't know anything about.
Okay.
Okay,
We're finding that right now.
now I'm going to look for something on my formula sheet. So I'm on to the not unit circle side. And
Middle one.
Computer code.
There you go.
look at this formula right here. This is what matches. The sine of
Yep, that matched. I knew it is.
one angle subtract another angle.
I should tell.
Oh, that's completely.
Okay? So angle A subtract angle B. That's what we just did, right? So sine A cos B. So sine 45 cos 30. I'm replacing the formula sheet. Please follow along your formula sheet. Subtract the cos of A sine of B. So that was me doing formula sheet replacement.
Because you're minusing the sign of that.
I was copying. So I copied that formula. Obviously, A was 45 degrees and B was 30 because that's what we wrote down, right? Okay, I'm going to put,
Plus.
no, it was a subtraction symbol, wasn't it? Right here,
Oh.
subtract.
What were
Were you looking in the wrong spot?
Yeah,
Okay, I put 4 brackets here and we're going to replace. So, what is the, now I'm back to my unit circle. What is the sine number at 45 degrees? So, at 45 degrees, what's the y value? Root 2 over 2. What is the cos? So, what is the x value at 30 degrees? Root 3 over 2. What is the cos? So what is the x value at 45? Root 2 over 2. And what is the sine? So what is the y value at 30? 1/2. Okay, now, how do you multiply stuff when there's radicals? So radicals can go with other radicals. So this makes a root 6 over, what's the bottom? A 2 on the bottom and a 2 on the bottom. So 4 minus, then this makes a root 2 over 4.
Good.
Yeah, good. That's right.
4 over 4.
Okay, I'm just going to put that together.
Can't just combine them.
You cannot combine radicals. You can't say that is a root 4, by the way. That's what you're trying to do. You can't put radicals together. You can multiply them together, but you can't add them together, right? And here's the last step. I'm going to ask myself about Astica. And 15 degrees is in this angle, or in this quadrant. So sine should be what? Sine should be positive there. So we're done.
Just say orange if we go.
That's it.
Because usually like
Okay,
jumbo.
I'm gonna do something where you're actually never gonna do it, ever, but I'm gonna show you. So what is the sine of 15.2588? Okay, got that value in your head? What is the square root of 6 minus the square root of 2 divided by 4? You ready?
0.25688 or something.
2.2588. That is what we just did. Okay, but you're not allowed to use your calculator.
Shoot.
And if you ever gave me a decimal answer, you would get 0 points. So, okay. This is an exact value. Exact value. There's no decimals and no rounding.
Because it would be cheating.
I just used it to check my answer.
Little Apple Watch or something we have
If you were to have a calculator on your test and that section, go ahead and check like I just did. But that's about it.
Or we can, oh, I see.
We should make a clock that has a unit circle, but it's like a clock.
Okay.
It's like a math.
I feel like a math lady's dream.
5 pi over 12. Where are we? We just wrote these out, so
I like following along. I don't want to do it by myself.
Yeah, this workbooklet's gonna be a rough patch. This is on Thursday.
boom. That's where I am, right? And would you agree with me that that is a 75-degree amount
Sure.
Yep.
from the axis, the x-axis?
Yep.
So we are going to be working with a 75-degree angle. So we're going to be doing some adding. Now, I don't like using cosecant. So this whole question, I'm not going to work in cosecant. What could I work in instead? What's the flip of that? Sine. So I'm going to do the sine of, and then I'm going to, instead of doing 75, I'm going to change that. Okay. Now I'm going to go to my formula sheet, and I'm now looking here, the sine of A plus B,
Whoa, whoa.
the sine of two angles added, okay?
Oh.
So I'm going to go
No, I don't. But
sine 45 cos 30 plus cos 45 sine 30.
you have to like.
So that was me just copying down a formula, but obviously plugging in. Give yourself 4 brackets to fill in. You want to know how I make my life easier? I just do the 45s. Because guess what? 45 is no matter what, root 2 over 2.
Yeah. No,
Right? X's and Y's. Everything at 45 degrees is root 2 over 2.
Right, yes.
And then 30,
Oh, yeah, I see. Yeah.
one of them is root 3 over 2, and one of them is a half. And just make sure you put down where you want which one. So root 6 plus a root 2 over 4. You see where I'm getting those values from? This was a root 6 on the top. This is a root 2 over the top. I can put them over the same bottom. Okay, now we did the sine, but the question asked for the cosecant. So what should I do now with my answer?
Flip it.
I need to flip it.
Can you push it up a little bit?
So there's my new answer because I flipped it. And I'm in the Astica, and this was all about sine, right? If it's about cosecant, it's also about sine, and sine is positive. So we're good.
Are you figuring it out?
What?
Are you figuring that out?
The Astica?
Yeah. Can you just say that again?
I'm in quadrant 1 because remember we talked about where it was at the start. And then if I'm there, the sign with Astica will be positive.
Oh, right.
So I'm good. I just leave it. Okay.
She just said that to me.
23 pi over 12. We are
Quad 4.
in quadrant 4. How many degrees are you off of the x-axis? 15 or 75?
15.
You're 15 degree away. So we're going to subtract then. Okay, I am not going to do secant. So what should I do instead? Cos 45 minus 30. Okay, so you have to go to your formula sheet and you have to find something that looks like the cos of two angles subtracted. So you're doing, I like to say this, cos cos plus sine sine. Cos cos plus sine sine. Did you notice that, this is what I always remember, the sine formulas always have the same symbol, and the cosine formulas always do the opposite. So if you subtract angles, the formula actually added. I don't know.
Well, then freaking 10 is like a...
But you,
I'm gonna ask the bonus question.
what's up?
Do we have to memorize these
Oh,
or
no,
what?
no,
Okay.
no. I give you the formula sheet, but. Okay,
I'm gonna ask the big question.
here's your 4 positions to fill in. Guess what? I'm going to start with root 2 over 2. And then you're going to get good at these because these are the 4 trig values you keep reusing.
30.
Okay.
I know that's 32. 32, right?
Okay. Now, we did cos, but I asked you secant, so I need to flip it around.
What's 2? Oh, I just wrote it down.
Yes, cosine. You don't do-
And Astica we're in the C quadrant, positive, so I don't have to do anything. I need to change this up. I need to get a negative one in here. Should change my notes around. Okay, last question. Cos is positive in quadrant 4. We were doing secant, which is in turn cos, and cos was positive in quadrant 4.
Why don't we just go equals, okay?
It's not about that. It's about Astica. It's about if my angle.
It's me right here.
195.
Right here.
Where am I?
13 over 12.
So,
You see my drawing here, Yuri?
is that adding?
If I'm here, the cosine
45 minus
value would be positive because of just Astica. That's all you're looking at.
Oh, yeah.
Location, Astica.
Minus 40. No, it would be 45 minus.
Okay, I need to understand where I am. 555 degrees. So that is 360 plus, how much do you want to keep going to get up to 555? 360 plus
85 or 80, another half, and then a little one.
another half and another little one.
Yeah, it's a little one.
Was it just 195 more?
Oh, yeah. 2.
Well spoken.
Okay, so a circle, another half circle, and a little bit more. Gotcha. 195 degrees puts me there.
We're in the festival mindset. We're done with this.
Okay, how much am I off of the axis? What am I, a 15 or a 75? I'm a 15 degree. When I say that, it's just the reference amount, guys. I'm either 15 or 75 referenced. So I'm going to do 45 minus 30, right?
Yeah.
So what is the sine of 45 minus 30? Are you okay if we just say example number 1? We did all this work before, so I'm just going to say look at example number 1. what did we write? Root 6 minus root 2 over 4. This is all we did in example 1 because we had the exact same question. But
What?
what about sign in this quadrant? It's negative. So this is important. You have to actually bracket that whole number and then write the negative out front. But you have to have the brackets on it. Because I don't want just the negative on the root 6. I want it as the whole number gets negated.
So it's in the third quadrant, and it's not 10. Okay.
Okay. Are we doing a tan one?
Yeah, example 5, find 10.
Okay, let's do a tan one. Okay. 285 is
Well, 1 in the fourth quadrant.
Yeah, sick.
10 of 285. Okay, so there I am. And it is a 75 degree referenced amount.
Plus.
So I'm going to do 75, so that's 45 plus 30. Okay, the tan formula is a little bit trickier. So the tan of 45 plus the tan of 30.
There you go.
Over
10 either way.
1, 10, 45, 10, 30.
Okay, so let's talk about this separately. What is the tangent of 45 degrees? We should just know that by looking at it from the unit circle.
1.
1. Remember that? Y divided by x, you're going to get a 1 there. So root 2 over 2 divided by root 2 over 2 will get you a 1. You don't need to write that out, but that's what's happening. The same thing divided by the same thing gets you 1. The tan of 30 would be y divided by x. What happens on the flip multiply situation on that? What do you think is going to happen?
2's cancel.
The 2's are going to cancel, so 1 over root 3. Okay, now we're going to be adding fractions. So that means I need to have stuff with the same bottom. Okay, how could I change 1 so that I match the bottom of this? Root 3 over root 3. Root 3 over root 3.
Can you change the second one on the bottom to root 3 again, or no?
I changed this,
Not the other one?
no,
Oh, 'cause that's
because
multiplying.
it's multiplying.
Yeah, yeah, yeah.
So then I don't need common denominators with multiplying. Because if you did, it would just cancel the root 3.
Right.
The heck is up 30
And then you would just give right back.
Yeah, what?
Yeah,
Okay.
this is, where's where I'm starting to forget.
Are you following my math? It's just looking a little tricky. Okay, okay, I separated these values, right? Were you
Right where we are right now.
right here?
Understand.
So this number was 1. But to add it, I need this number and this number to have the same bottom. So how do you make it with a bottom of root 3? well, root 3 over root 3. Anything that's the same over the same is a 1. So now those have the same bottom. So I go root 3 plus 1 on the top over a root 3. And then I just did the exact same thing on the bottom. I changed this to root 3 over root 3 so that I can add it to this value because it has a root 3 on the bottom. Okay?
Can you just kind of ignore the 1 because it's just a 1?
I just ignored this like that. Is that what you mean?
Yeah.
Yeah. Just ignored it because it was 1 times something. Okay. Do you understand this would get flip multiplied?
Yeah.
And what would happen?
The root 3's would cancel.
The root 3's would cancel. So root 3 plus 1 over root 3 minus 1. And last, what's going on with Astica there?
What is it? It's a negative.
It is tan negative. So again, bracket, boom, negative.
But you would know that